Okay, guys, in this unit we're discussing water resource use, and last time we really discussed how very little fresh water is available for us to drink and to use. And so one of the some strategies for expanding the amount of water that we have available to us is extracting groundwater. And this is a great idea in many cases because as you pump it out of the ground, you can drink it and irrigate your crops with it without any type of treatment. As you're going to see in a few slides, it does exist almost everywhere in the world. And as long as you're not pumping it out too quickly, it can percolate back into the ground and replenish that aquifer, and it will not run out. The other thing is that once you have your well built, it's actually cheaper than treatment of surface waters. So groundwater is a really, really good resource. One of the problems, though, is that we're pumping the aquifers faster than what they can be replenished. And so that's, in some cases, is causing subsidence, which is the sinking of the ground. Some of the wells are quite a ways down there, and the deeper the wells, the more expensive they are to drill. And one of the problems with using the groundwater is that if the well is contaminated, that pollution is going to be down there for centuries. It's not easy to clean up. So there are some pros and cons to using groundwater. You do need to know the Ogallala Aquifer, which is the largest known aquifer in the world. It's right here in the U.S. Below the Great Plains. And it's just one of many different aquifers, as you can see from this slide. Groundwater is, in fact, almost everywhere. One of the problems, though, with the Ogallala, as we mentioned in this slide here, is that we're pumping it out up to 40 times faster than it can be recharged. It's actually a slow recharge aquifer. One of the things that's encouraging this is government subsidies that goes towards unsustainable farming. And it's not that we're against subsidies towards farmers, it's just asking the question, is there a better way that we can frame those subsidies to encourage more sustainable practices? Let's just give you some examples here. Oh, by the way, in addition to the aquifers in the U.S. here's a slide that shows some of the major aquifers around the world, and you'll notice through Africa and the Middle East, there is groundwater there. It's just a matter of drilling down and getting to that water. Now, in terms of our overdraft and overuse of the Ogallala, you'll notice that through the heart of the country, we have high overdrafts, meaning we're pulling water out of the ground faster than it can recharge. On the slide on the right, you'll notice that in some areas in the darkest red, we have water level changes of more than 45 meters, which is about 150 feet. So the water table has dropped over 150 feet in some areas of Texas and Kansas. Now the deal is as you overpump, it becomes more expensive to go deeper to get the water, which means it's going to get passed on in our prices of food production, which only causes a bigger gap between the wealthy and the poor, which is obviously an issue. Poverty being one of the primary issues environmentally worldwide. It also causes land to sink. In this slide here, you'll notice how far the land has sunk in the San Joaquin Valley. This goes back decades and decades, but it gives you an idea of just how much the land can and does sink when you overpump these aquifers. So what do we do about it? Well, first of all, if you can use the water more efficiently, obviously you're not going to need to pump as much water out of the ground. Subsidizing water conservation simply says that we are still going to be subsidizing our farming, but yet in return we'll be asking the agricultural industry to use more conservation practices. You can also limit the number of wells. Simply saying if you don't have as many wells, you can't pump more water out of the ground. And then finally, we have ways of why not just not use water-thirsty crops in these dry areas. Why grow corn in areas that corn really shouldn't be grown, for example? That would limit the amount of water that's necessary. Try to grow more drought-tolerant types of plants. The other thing that we can do to control prices is to simply raise the price of water to discourage the waste, meaning, hey, the more expensive something is, people tend to take care of those resources a little more carefully. You can also tax the water that's pumped near the surface. And that is to say, if you're going to go get the easiest water, you're going to pay a premium price for that. If you're going to spend the money into investing into deeper drills and deeper wells, well, then you won't have to pay as much as a tax there. And then by doing so, you're going to be spreading out the areas from which we're withdrawing water. The building of rain gardens in urban areas is simply a way to collect rainwater. How do you collect all the water that's coming off these impervious roofs, streets, sidewalks, parking lots, etc.? Well, if you can trap that water, you can potentially use that water. And speaking of all these impermeable surfaces, what if in the next generation we start using permeable pavement on our streets and sidewalks, etc.? What that would allow to happen is for the water not to just rush off into a gutter and then flood. What it would do is it would allow the water to seep through the asphalt, through the concrete, and actually get into the ground and seep down to the water tables that are declining because of overpumping. So those are just a few ideas and solutions to our groundwater problem. We do have some deeper aquifers than what we thought. There may be more water down in the ground than what we have previously believed. We don't know about the impacts of pumping some of these deep aquifers. Some of the problems is that these deep aquifers run below more than one country. And so the idea is that you're going to have some type of agreement between countries, similar to what you would have with oil, for example. All right. In the next podcast, we're going to take a look at how we can expand water resources through dams. So in addition to using groundwater, how else can we get additional water? So one way is through building of dams. All right. Two of the more famous dams here in the U.S. would be the Hoover Dam, which is in the lower left, and the Glen Canyon Dam, which is in the upper right. And essentially what they did is you have the Colorado River that's running through the bottom of the canyons. They build the dams, all right, which are going to be right here. That's the Hoover Dam, and that's the Glen Canyon Dam. And then you just wait for the river to fill up the lake behind the dam. Behind the Hoover Dam is Lake Mead, and behind the Glen Canyon Dam is Lake Powell. It took about 6 years for the Colorado River to fill up Lake Mead behind the Hoover Dam. It's just an amazing engineering marvel. Take a special note of the light-colored rings that are in the canyon. That shows how much water has evaporated out of the lake from its maximum level. We'll talk about that more here in just a few slides. Another major dam was built in China called the Three Gorges Dam. This is one of the largest dams in the world. You'll notice that it's built in pretty much in central China. And just to show you the difference in water level, what happens behind these dams, on the bottom section, you'll notice the Yellow River that's flowing through, all right, here. And then just you'll notice here's where the dam was built, and you can see how much water backfilled behind the canyon, or behind the dam in the canyon behind it. All right, and so there are some issues with the amount of water that it fills back behind these dams. So the idea here is to store all the runoff. We said that 2/3 of the runoff is not reliable, and one of the great things that the dams do is that they actually trap water runoff, which can be a good thing. It controls floods. You can generate electricity with it. And then with these huge lakes, you now have a good supply of irrigation and drinking water, and then you can also use it for sport. So just to run down through some of the advantages that are on the right here in green, first and foremost, it does provide irrigation water and drinking water for both above and below. You can pump the water directly out of the lake and irrigate your crops with it, or you can treat the water through water treatment plants and then pipe it to people's homes. It's also really good for skiing and boating and those types of things. I have a family member who lived on the backwaters of the Kentucky River, and it made for great fishing, great boating. For reasons we'll get into in a future chapter, it can also produce hydroelectric power as well. And one of you guys will be giving a presentation on how hydroelectric power works. And again, one of the beautiful things is it does reduce flooding downstream. That's a big deal. Now, for some of the disadvantages on the right here, we said that how much water fills up behind these dams. It fills up the canyon or the land back behind it, and that's going to destroy forests. There could be farms back there. People live in some of these areas, and they have to be removed from their homes through eminent domain. And so that's really one of the big disadvantages. Also, with these lakes, you actually lose a lot of water through evaporation. And in fact, remember the rings that we were showing, and they sort of show it in this image here. But the level of these lakes are dropping drastically, and so that can become an issue. One of the big issues also is going to be prevention of silt going downstream. Remember in a previous chapter we talked about the fact that these the silt, if it doesn't get to the mouth of the river deltas are actually sinking, and so that's an issue. Also, if the silt can't get downstream, that's all nutrients for the estuaries or for croplands in the case of the natural flooding that used to be relied on. Just think about the Nile River. And the reason why people settle along the Nile is for the seasonal floodings that would dump silt onto the landscape, and then they could farm that. You also have issues with possible devastating floods if the dam is breached. And in fact, the Glen Canyon Dam they're a little bit concerned about that because of the sandstone walls that the canyon is made up of. And if that sandstone gives way, you could have massive flooding downstream. And then finally, the spawning of fish. Fish will spawn naturally where they were hatched, but if they were hatched above the dam, they have no way of getting back above the dam to spawn, and so it disrupts a lot of the fish cycles. We're going to bypass how a dam works, and somebody will be doing a presentation later than that. And so we've already mentioned the fact that these dams, how they killed the Colorado River downstream, going to the Gulf of California. You saw that in the video clip that we showed in class. We've already mentioned the reservoirs, how much water gets evaporated, and then also the silt. Not only does the silt not get downstream, so it's not usable, once that silt fills up, it continues to fill up behind the dam, then the dam becomes unusable because the silt will cover up the water intakes that are used for the power plant. All right, and this image should look familiar from the Colorado River video clip that we looked at the beginning of this unit. All right, and so in the next podcast, we're going to take a look at water transfers. Is it possible to pipe water from place